Let's do a weird exercise together. Let's imagine throwing a ball along the floor. Yeah, I said throwing, not rolling. Bear with me, there's a method to my madness here. If we throw the ball along the floor, a couple of things are going to start happening. Number one, the ball may actually start rolling on its own as it interacts with the roughness of the floor and the friction between the ball and the floor. And the ball also could start bouncing. The ball is riding up and down over the lumps in the floor, those things that make the floor appear not flat. So the same floor has roughness and what we would call waviness hiding inside the surface. Now, in a previous session, we talked about what is roughness, and we talked about roads, and we introduced the cool lambda symbol indicating wavelength. Well, our floor and our rolling ball situation has the same situation, only here we're going to name roughness and waviness to be the things that make the ball roll and the things that make the ball bounce. So now we need to engineer this. We need to be smarter. We need to design floors for optimal performance. When we do this, we need to control roughness and waviness perhaps independently. We need some amount of roughness so people don't fall down, and controlling waviness so the floor looks flat. We might end up with a surface that looks like this that we need to describe and control. So for this particular floor measurement, let's determine the waviness. The way we do this is to average our way through the surface. We're going to average some points and plot the result. And then I'm going to move that average over just one tiny data point to the right, and we're going to calculate an average for that region and plot that point. And if I keep averaging my way through the surface, I'll come up with a smooth shape, and that smooth shape is the thing that we are calling waviness. This process of averaging our way through a data set has a sexy math term called convolution. Yeah, you can use that with your friends. I'm sure they'll be impressed. Now, once we have this waviness shape through the middle of our data, we could look at everything above and below it, and that is our roughness. We have a peak right here that is above the waviness profile. We have a valley right there that is below the waviness profile. These peaks and valleys of roughness are all of the features that are below or above the waviness line. Let me say that properly and get the order right. A peak above the waviness line is a peak in the roughness profile. So roughness is what we get when we subtract waviness from our original data. Now, this convolution, there I used the word again, is something we're going to improve on in the next session. Simple moving averages aren't that great, but we've got a better way. Stay tuned.